Assalamu alaikum and good day. My name is Muhammad Mahadi Hassan Imran, and today I am going to talk about my final year project FYP1, and my title is Autonomous Ship Maneuvering Using Artificial Neural Network. Before I go into my main presentation, please allow me to talk a bit about my title. So I have divided my title into two parts. First is autonomous ship and second one is artificial neural network. So what is autonomous ship? According to the researcher, autonomous ship is a periodically unmanned ship, and ship can operate without crew, and ship consists of various sensors to detect the navigation path. So we can say a vessel consists of sensor to detect navigation path and able to operate without crew for a period. And what is artificial neural network? So artificial neural network is a machine learning algorithm consists of the input hidden output layers, has the capability to replicate human brains, also capability to reproducing desired output even through there is a lack of information. So we can say that ANN is a machine learning algorithm that can perform as human brain and provide intelligent decision even lack of information. So here is the content I am going to talk. Firstly, background of the study, then problem statement, then objectives, then scope of the research, literature review, methodology, and finally the expected result. So this is the background of the study. The autonomous ship technology has formed a leading issue due more efficient and safer sea transportation solutions. The concept of an autonomous ship is highly driven by machine learning and deep learning. An ANN is a kind of machine learning algorithm. It is trained through trial and error method since there is no specific rules for the structure. In case of autonomous ship maneuvering, artificial neural networks are used for minimizing the errors in predicting the ship trajectory. Here is the problem statement. Sometimes human brain is not capable to solve complex data and cannot extract information from compound structures, and due to this ability of provide proper decision, many accidents occurred and provide gradual ship maneuvering. Compared to human brain, ANN can provide more accurate decision. So after studying 121 article related autonomous ship maneuvering, I found there is no research done using ANN for autonomous ship maneuvering. I have three objectives. Firstly, to construct an ANN based on distance sensor reading with which outputs throttle and rudder angle. Secondly, to evaluate the performance of the artificial neural network based both, both in a simple track. And thirdly, to access the capability of artificial neural network based both to avoid obstacle. And the scope of my research is I only use artificial neural network and genetic algorithm, and there is a specific dimension of ASV will be used as agent, and simulation environment will create within Unity Physics Engine software. Here is the literature review. According to my first objective, I have searched for available ANN models capable to autonomous ship maneuvering task, and I have found 25 methods that have used to autonomous maneuvering. You may have a look, you may pause the video and have a look. This is the literature according to my second objective, review on available ANN work for maneuvering task, and I have found 34 method is using. So as well as you may pause the video and look at the methods that I have found. This literature review is based on my third objective, and I've searched the use of artificial intelligence in port monitoring. So due to short time, you may pause the video and look about the method I have found. I just found 18 methods, but have many. The methodology. Firstly, I will select artificial neural network and genetic algorithm, then construct navigation route or track. Thirdly, train ANN-based distance sensor reading and evaluate the performance of ANN in the experimental track by simulation. And finally, evaluate the capability of the avoid obstacle. This is the first methodology, and I am going to use this code to create genetic algorithm. This is the second step of my methodology part is construct navigation route and track. So if you look at this picture, this is the track that the simulation will run in this track, and this is the characteristics of this track like 4 sharp, U-turns, 1 sharp, 90-degree, so on. And this is the train ANN based distance sensor. So if you look at this vessel ASV, so there are different 9 sensors that will be act to detect the obstacle, and here is the ASV, and the dimension is given here. And finally, I will evaluate the performance of ANN in the experimental track by simulation and evaluate the capability of to avoid obstacles. Expected results. Considering the previous literatures, the ANN will be able to provide effective performance in particular track. The prime focus of this research is to develop an AN-based distance sensor which is extremely suitable to avoid obstacle. After finishing the research, it is expected that the proposed methodology will be able to meet the concurrent requirements. And here is the review. Of course, the title is Autonomous Ship Maneuvering Using Artificial Neural Network, and this is the background of study. Many accidents occurs during maneuvering due to wrong decisions by human, so that artificial intelligence is using to create autonomous ship in order to efficient and safe navigation. The problem statement is after study 121 article related autonomous maneuvering, there is no research done using ANN for autonomous ship maneuvering. And the objectives, three objectives was to construct an ANN based on distance sensor reading which outputs throttle and rudder angle, evaluate the performance and in simulation track, and access the capability to avoid obstacle. And the methodology, firstly we have to create the select the ANN and GA, construct the track, then train the ANN and evaluate the performance of the ANN in track. Finally, evaluate the capability of obstacle. And the scope of the research is we'll use ANN, GA and ASB with a specific dimension. And simulation environment will be created in Unity physics engine software. Thank you very much.